Hello, today we're going to do a quick review for our first midterm exam. So we're going to go through the topics that we've covered here in the first 5 weeks of the course. So the first big area, the first chapter 1, remember, was our vocabulary and introductory terms. Biggest things in the vocabulary you'll need to be able to identify. You'll need to be able to identify what is a population and what is a sample. And you may either need to be able to define them, to write out a definition of them, or to match them with their definition, or you may need to be able to pick out of a situation. If I give you a scenario, pick out what is the population and what is a sample. Along with that, excuse me, you need to know what is a parameter. You need to know that a parameter is that piece of information that describes the population, or a statistic. That's that piece of information that describes the sample itself. Now, by parameter, by describing the population, I'm not saying, oh, the population is all voters in America. No, I mean by saying it needs to be a numerical answer. It has to be related to our variable that we're asking, the question we're asking. So that the parameter might be, we estimate that 40% of all voters are going to vote this way. That is describing the population. I'm not trying to define the population. I'm trying to describe a characteristic of that population. And again, the statistic doing the same for the sample. Again, you may not need to define the terms. You might match them with a definition, or you might, in a scenario, pick out a number that's a parameter or a number that's a statistic. Along with that, you might be able to pick out a piece of data. What is our variable of interest, or a random variable? Is that random variable numerical or categorical? Is it qualitative, categorical, or is it quantitative? Numerical. When I think quantitative, I think quantity, which is a number. So that's how I remember it. Quantity is numerical. And along with that, levels of measurement. Is it ordinal or nominal? So nominal or ordinal for qualitative. Quantitative, of course, we have to define whether it's discrete or continuous. Discrete, remember, is counted. It can be counted or listed. So discrete, you can list out all the possibilities. Continuous is measured. And I'm not going to write it out, but remember we talked about continuous. No matter how close together two numbers are, there's always numbers in between them. And then, of course, you have your ratio and interval levels of measurement within those. You might need to be able to define the types of samples. Simple random sample, of course, is the big one. Sometimes abbreviated just SRS. Stratified. That's where you divide the group into the population into different groups and select a certain number from each group. Cluster. A cluster sample. You still divide the population into groups, but then you select whole groups. Strategic, or systematic, I should say, is the word that this textbook uses. Systematic, where you randomly select a starting point, and then the system determines all the other ones. And then, of course, convenience, which we know is not really truly random. And many of these up here are considered samples of convenience. They're not simple random samples. But these are still random, even though they are considered less than perfect. The simple random sample is statistically the ideal way, but sometimes the situation calls for less precise methods or somewhat less random methods. These are still random, they're just not simple random. And of course, remember, convenience sample, an absolute convenience sample is not random. Like just going out and selecting the first 10 people you see, that's not random. Okay, so, and again, those you may need to be define them, match them up with a definition, or given a situation, tell what type of a sample that is being described in that situation. What type of sampling was used in that situation. Then we have to define an experiment. Oops, back to black. Experiment is an observational study. Is an experiment that we actually created. I mean, is it the types of experiment? There's a blind experiment. There's double blind experiments. What those terms mean as far as who knows what's going on, who doesn't. You need to be able to pick out, we set up here what the random variable, I should mention. Either in a scenario, pick out what the random variable is or define what a random variable is. Same with a piece of data, just like everything else. You need to be able to deal with frequency tables. You need to be able to create them. If we give you the list of data, put it into the frequency table. If you have a frequency table, you need to be able to create the relative frequency table. Might need to be able to create a cumulative frequency table. Now, a relative frequency can apply to both qualitative or quantitative. Cumulative frequency table only applies to quantitative, numerical data, because there's no natural order for the categorical, so there's no real cumulative. So if you know that vocabulary, that goes a long way. Next, you need to understand the empirical rule. And of course, that empirical rule is the bell curve and the percents that get put in there. And of course, this is the mean in the middle and going out one standard deviation and steps of one standard deviation each side, and then of course the standard percents. Telling you that we expect what percent of the data to be within one standard deviation of the mean. Well, we expect that to be 68%. And we expect 95% to be within two standard deviations. And almost all or sometimes specified as 99.7% to be within three standard deviations. Anything outside of that, three standard deviations, of course, is considered an outlier on either end. Also need to use z-scores. You need to use z-scores to compare two values. For example, if I give you that there's a mean, I'm just going to use some simple numbers here, of 25 and a standard deviation of 5, find the z-score for x equals 37. Well, we're going to take x minus the mean, so that z-score is going to be x of 37 minus the mean of 25, and that difference divided by our standard deviation. 37 minus 25 is 12, divided by 5 is 2.4. So it's positive, which tells us that our score, our value is above the mean. If it was negative, it would say it was below the mean. And it's 2.4 standard deviations away from the mean. So 2 point standard deviations above the mean for that value. Now, related to that, we could ask, what value has a z-score of a negative 1.6? So now we're going to have to do some algebra. We've got this formula here, but we're going to put in the z-score. Negative 1.6 here equals our value x minus the mean is still 25, and the standard deviation is 5. So we do our algebra to solve that. We're going to multiply by 5. So that's negative 8 equals x minus 25. And we add 25 to both sides. So negative 8 plus 25 is 17 equals x. So the value that corresponds to a z-score of negative 1.6 is x equals 17. We're going to deal with contingency tables. Being able to find probabilities from that contingency table. Let me do a quick little thing here. Let's do, so students are in class and face-to-face, or online. So face-to-face versus online. Let's do pass and fail. This is a really quick, simple contingency table. So let's say that what we have here is we've got 40 and students that are in class that pass, 10 who fail. Online, let's say we have, oh, what do I put in here? Let's do 38 who pass and 12 who fail. With any contingency table, the first thing you want to do is you want to find totals. You want to find row totals. So 40 plus 10 is 50. 38 plus 12 is also 50. And you got to do column totals. 40 plus 38 is 78. 10 plus 12 is 22. And then, of course, a grand total. Both directions here better add up to the same thing. Both the 50 plus 50 is 100, 78 plus 22 is 100. And then we have probabilities we can get from this. But what is the probability that a randomly selected student is online? This is online. There's 50 online out of 100. So it's 50 out of 100. We divide that out to be 0.5. Probability that a randomly selected student failed. There's 22 here that failed out of 100. So 22 out of 100, or divide that out to get 0.22. Probability that a randomly selected student is in class and failed. So now in class and failed is the 10 here. So that's 10 out of 100, or divide that out to get 0.1. So now let's do, that's an and. This is and. So that means it has to meet both qualifications. So it's just a single number where the that's why they use the term intersection. They might use the phrase, P in class intersect failing. The reason it's called an intersection is on the table here. That's where the in class row intersects the failed column. We might ask probability that they online or they pass. Well, here's online, here's passing. Remember, we have two options. We add up the individual values, the 48, 38, or 40, 38, and 12, which would add up to 90 out of 100. So 40, plus 38 plus 12 over 100 is 90 over 100. Or we could do that inclusion-exclusion thing, that the addition property, the full addition property, where we add them together. We're going to add together the online, which is 50, plus the pass, which is 78. Then we have to subtract out those that were both. There's 38 that were both online and passed. That's out of 100. And of course, that still comes out to 90 out of 100, or 0.9. So we can do it either way. You can add up the individual values or row total, column total, remembering to subtract out where they overlap. The technical terminology for that, the technical way that was written out was, that is the P of online plus, probability of online plus probability of pass minus the probability of both online and pass. Kind of ran out of room there, but you know what I was writing. Next, we want to talk about conditional probability. What is the probability that a student is going to pass given that they're online? So it's this second one that narrows our viewpoint. We're only looking at students that are online. So now we're not looking at the whole table, we're only looking at this row, students that are online. Well, there's 38 who pass out of 50 total. So that's 38 out of 50. Notice our viewpoint was narrowed down to only those that were online. Or we might do it the other way around. What's the probability that someone was an online student given that we know that they passed? So now we're not narrowing it down to the online, we're narrowing it down to those who passed. This column. So there's 78 in that column. There were 38 that were online out of that 78. So this is 38 out of 78 that you can divide out. You'll also have to be aware of, with those frequency distributions, as I said, you need to be able to find relative frequency, cumulative frequency. Also, from the frequency distribution, you need to be able to find the midpoint if it is grouped data. So if I have 55 to 59.9, 60 to 64.9, 65 to 69.9, my midpoint is found by taking the first numbers in each group and adding them together. So this is going to be 55 plus 60. So this midpoint here is going to be 55 plus 60 divided by 2. So that's going to end up being, what, 57.5. This one is going to be the first number of that class to the first number of the next class again. 60 plus 65 divided by 2, which ends up being 62.5. Now here, we don't have a next class, but we know that if there was, it would have started with 70. So we're going to use that. 65 and 70 divided by 2, so 67.5, and so on. Find those midpoints. Once you find the midpoints, you need to be able to find the mean of that group data, and of course the variance, and the standard deviation. If you look back in the week 3 and 4 recordings, contain information on those. You'll need to be able to use a probability distribution. First, you need to be able to find, is it verify that it is a real or a valid probability distribution. So let's have my values here. I'll call this x, and this is my probability of x. So let's say I have just the values 0, 1, 2, 3, and 4. So this is going to be 0.1, 0.15, 0.25, 0.2, and point. Let's make sure I get this to add up right. So make this 0.3 here. 0.3, and this will be 0.2. Those are my probabilities. So I need to be able to, first of all, find probabilities. So I might have, what is the probability that x equals 2? Well, that's pretty simple. I just pick out the 2 here. That's 0.25. A little trickier is I might have to find probability that x is at least 2. Now, at least, does that include the 2? Yes, it does. 2 would be at least 2. So that's 2 all the way down to 4. So I'm going to add up those probabilities. 0.25 plus 0.3 plus 0.2, which adds up to 0.75. If I ask the probability that x is more than 2, now that does not include the 2. 2 is not more than 2. So that's only the 3 and the 4. So we just add those two together, giving us 0.5. And the same on the other end. We could ask probability that x is less than 2. That doesn't include the 2. Less than 2 would be just the 0 and 1 added together, so 0.25. But we could ask probability x is no more than 2. That does include the 2, so it's 0, 1, and 2 now. So now that adds up to 0.5, and so on. So you have to be able to find those probabilities and know these terms. When it's less than or greater than, does it include the number or not? Is it inclusive or exclusive? Or we might ask between 1 and 3, inclusive or not inclusive. Know those terms. You also need to be able to find the mean, which is also the expected value. And the variance and standard deviation. Along with that expected value, of course, there's that idea of what's a fair game and stuff. We usually don't attack that on the test, but it's something to know. That's one of the biggest applications of the mean or the expected value. And it may pop up. You never know. So that idea of a fair game. Remember, a fair game, the expected value is 0. Okay, so the next, you want to be able to use just relative frequency probabilities or empirical probabilities. Where we say, hey, out of 200 parts, 35 have this characteristic and blah, blah. Okay, what's the probability that a given part has this characteristic or whatever? Or we might say that out of 40 traffic tickets written this week, 12 were for speeding, 19 were for stop sign violations, 9 were for seatbelts, whatever. Now, what is the probability that a randomly selected person would, a randomly selected ticket was a speed violation or whatever? Let's see here. You need to be able to use binomial probabilities. First thing you need to be able to know is the 5 requirements. You need to have those memorized and be able to identify if a situation fits those. Remember, there's the 3 Bernoulli requirements. One is only 2 outcomes, success or failure, for each trial, of course. And the probability of success, P of S, or little p, is constant, stays the same, does not change from trial to trial. Trials are independent. And then, so those are the Bernoulli requirements that we talked about in our lecture. The book doesn't use the term Bernoulli, but those are the things we talked about for each individual trial. And then, when we group them all together into the binomial situation, the 4th and 5th requirement. The 4th one is that there are a fixed number of trials. That fixed number is n. And 5, of course, that x, the random variable, x, is the number of successes in the n trials. So you can identify to verify that it is a binomial experiment or binomial situation. The biggest thing you're going to look for is a percent, but remember the percent has to apply to a larger group, a larger population. It has to be derived from that larger population, and then we're going to try to apply it to a smaller sample. So we might be looking at, where they state 42% of all students have to retake at least one class or in college, so on. So I'm going to say, well, in a sample of 12 students, blah, blah, blah. And then you need to know, we just went over this in the last week's recording, so I'm going to refer you to the week 5 recording if you want for this, but then you need to know what is the probability that x equals a given number, probability that x is less than a given number, probability that x is less than or equal to it. The whole less than or no more than or at most, at least, probably that x is greater than a number, or again, probably x is greater than or equal to the number, or the probability that x is between a certain numbers. Greater than or equal to would be inclusive, whatever. Now remember, this situation is the binomial PDF, probability distribution function. These two situations are CDF. But remember, the one that is not equal to, the one that's strictly less than, is, so you need to determine the strictly less than. Remember, you're using one less than whatever number is here. Less than or equal to, you're going to use the number that's in there. These, of course, it's going to be 1 minus that binomial CDF function to give you, because remember, the CDF is the number that are less or the number that are greater. So here you're actually going to subtract out whatever numbers here get subtracted out. Here it's 1 less than this number that's subtracted out, because since it's equal to what's included in. And again, I refer you to week 5 recording to get those calculations in more detail. We did those a lot more detailed. And then the one that's between here is going to be a CDF function minus another CDF function. So remember, the first one is this number here, if it's equal to. The second one is this number minus 1, because we want to include that one. We want to subtract everything out that's smaller than that. And then, of course, from there you need to be able to make our standard graphs and plots. After, I should note here in the binomial, you need to be able to find the mean, variance, and standard deviation of a binomial distribution. Remember, those are the shortcuts. The mean is just n times p, and then there's the other formulas. The variance is just n times p times 1 minus p. They sometimes use q instead of 1 minus p. Standard deviation is just the square root of the variance. So square root of n times p times 1 minus p. Then, like I was saying, you need to make the standard plots. You need to be able to do a stem and leaf. Stem and leaf plot, one-sided or two-sided. It could be a double stem and leaf plot or a single stem and leaf plot. You need to be able to make a box plot, box and whisker plot. Make sure you know how to identify outliers in a box and whisker plot. It's a little bit different than the empirical rule outliers are. You'll need to be able to do histograms, line plots. Histograms, line graphs, to be able to read off of those. That's pretty much it. I guess in this course we didn't cover any of the other real types like pie graphs or circle graphs or anything like that. You need to be able to read data off of those types of graphs, however, if you need to, so you need to not only be able to construct, be able to create, and to be able to read these if information is given in one of those forms, to be able to read information off of. So that is a summary of what would be expected on this test. If you have any questions, please let me know. Otherwise, good luck on the test. Let me know if you need anything, and I'll get back to you as soon as I can. Otherwise, you have a great week.